June 2016. Code Conference, Rancho Palos Verdes, California. Elon Musk is on stage talking about video games, specifically Pong, two rectangles and a dot in the year 1972. Fast forward 40 years and we have photorealistic three-dimensional worlds with millions of simultaneous players. Virtual reality that tricks your senses. Games indistinguishable from reality. If civilization continues improving at any rate at all, eventually we create perfect simulations. And if we can create perfect simulations, we probably create billions of them, which means statistically, you're probably in one.
It would seem to follow that the odds that we're in base reality is 1 in billions, is 1 in billions, is 1 in billions.
The odds that we're in base reality is 1 in billions, Musk muses. The audience laughs nervously, because he's not joking. And neither are the physicists who've spent decades proving that reality might actually be information all the way down, just maybe not the way Musk thinks. This is Theoretical Nonsense, and I'm Jake Vance. Today we're asking a question that sounds absurd until you look at the evidence. Is reality computational? Not are we in the matrix? That's actually the least interesting version of this question. The interesting version is more like, what if the universe operates on information-theoretic principles so fundamental that consciousness, physics, and reality itself are better understood as data processing than as matter moving through space? Because here's what's strange. 3 separate lines of investigation, quantum mechanics, theoretical physics, and consciousness research, are all pointing toward the same conclusion. Reality isn't made of stuff, it's made of information. And that has implications for everything we've discussed so far. Near-death experiences, remote viewing, and the nature of consciousness itself. Nick Bostrom, 2003, a philosopher at Oxford who made simulation theory academically respectable by wrapping it in probability math. His argument isn't, we're definitely simulated, it's, one of these 3 things must be true. Option 1, advanced civilizations go extinct before developing simulation technology. Option 2, advanced civilizations survive but choose not to run simulations. Or option 3, advanced civilizations survive, develop the technology, and run trillions of simulations, which means most conscious beings are simulated, which means you probably are too. Bostrom's point is, unless you think we're uniquely special, the one real civilization in a universe of fakes, you should bet on option 3, statistically speaking. Musk made it cool, but he's not alone. Rizwan Virk argues we're in a simulation based on video game design principles, level of detail rendering, procedural generation, and save states. And George Hott says the odds are basically 100%. Rich Terrell thinks Moore's law puts convincing simulations within decades. What about our friendly neighborhood astrophysicist, Neil deGrasse Tyson? Better than 50-50 odds. The idea penetrated. Reddit, startups, TikTok. Glitch in the matrix became shorthand for any coincidence. There's just one problem. The physics, as we understand them in this reality, doesn't work. Franco Vazza, 2025, astrophysicist at the University of Bologna. He actually did the math, used the holographic principle. We'll get to that in a bit, and calculated the computational requirements to simulate even a small piece of reality. The numbers are obscene. To simulate Earth alone, not the universe, just Earth, down to the resolution where you could detect neutrinos, you'd need a computer the size of Jupiter and the sun's output for 2 minutes just to initialize it. To simulate the observable universe, that would require more information than exists in the observable universe, which is a neat trick if you can manage it. Vazza's conclusion, the holographic principle doesn't support simulation theory, it disproves it, because the information-theoretic constraints that make reality computational also make simulating it physically impossible within our physics. Sean Carroll points out the logical trap. Bostrom's argument starts by assuming simulation is easy, that's why everyone does it. But if we're in a simulation, we're probably in a low-level one, the bottom of the stack, which means we shouldn't have the computational resources to create our own simulations. He says, the argument started with the premise that it wasn't that hard to imagine simulating a civilization, but the conclusion is that we shouldn't be able to do that at all. Basically, the simulation hypothesis eats itself. So why does it feel compelling? Let's talk about the most disturbing experiment in physics. Fire single photons, or particles of light, at a barrier with 2 slits. If you don't observe which slit the photon goes through, you get an interference pattern, also called wave behavior. as if the photon went through both slits simultaneously. However, if you measure which slit it passes through, if you observe it, the interference pattern vanishes and what you get is particle behavior. As if the act of observation collapsed the wave into a single dot, like a single particle, without a vague-looking wave pattern. Richard Feynman called this the heart of quantum mechanics, and it's also the heart of why people think we're in a simulation, because it looks exactly like a rendering optimization. Video games don't render what you're not looking at. The distant mountain isn't actually there until you turn the camera toward it. It's a probability field, data about where it should be, that gets actualized when observed. The universe does the same thing. Particles exist in superposition, kind of unrendered, until measurement forces them into definite states. Either quantum mechanics is revealing something deep about observation and reality, or the programmer is saving GPU cycles. And then there's the very strange observable phenomena of entanglement. Einstein called it spooky action at a distance and hated it. Don't ask me how, but if you create two entangled particles and then separate them by light years, something very odd occurs. Measure one, and the other instantly reflects the result. Not faster than light, because no information travels, but the correlation is instantaneous. Physicists use words like spin being up or down to describe what they're measuring. Entanglement is where measuring the spin of one particle instantly determines the spin of the other, regardless of distance. Before measurement, the particles exist in a state of superposition, where each particle's spin is simultaneously both up and down. Once measured, for example, if one particle's spin is measured as up, the other is immediately known to be down. How? The simulation answer is that they're both accessing the same data structure, and that distance is an interface illusion. The physics answer is that quantum mechanics is non-local, and that space is emergent. Notice those answers aren't that different. One says space and time isn't real depending on your perspective, and the other says space and time isn't real depending on your perspective. Reality also has what sounds like a resolution limit, the Planck length, 1.6 times 10 to the power of negative 35 meters. That's a decimal point and a lot of zeros. It's absurdly small. Below that, space and time stop making sense. Quantum foam. You can't subdivide any further without creating black holes. It's the pixel size of the universe, and that's exactly what you'd expect if reality were computational, a discrete grid, a smallest possible unit of space and time. But, and this is important, it's also exactly what you'd expect if general relativity and quantum mechanics are both true. The Planck scale is where the theories collide. So is space-time pixelated because it's simulated, or because that's how quantum gravity works? The evidence doesn't tell you. You're interpreting the data through your metaphysics. Now let's talk about the physics that actually matters here. We talked about how Franco Vazza used the holographic principle to calculate and disprove the simulation hypothesis. What exactly is the holographic principle? 1970s. Jacob Bekenstein and Stephen Hawking discover something bizarre about black holes. Their entropy, or the amount of information they contain, doesn't scale with volume. It scales with surface area, specifically the event horizon, the two-dimensional boundary. Maximum information equals 1/4 of the event horizon area, measured in Planck units, which means a black hole's information content is determined by its surface, not its interior, as if the three-dimensional reality inside is encoded on a two-dimensional boundary, as if 3D is a projection from 2D. Gerard de Hooft and Leonard Susskind took this seriously. If black holes work this way, maybe the entire universe works this way. Enter the holographic principle. All the information in a three-dimensional volume of space can be encoded on its two-dimensional boundary. Reality as we experience it, three spatial dimensions, objects with volume, matter moving through space, might be a projection from information stored on a distant surface. Suskind's reaction? It just had to be correct. It couldn't not be correct. Based on the thermodynamics of black holes, the principle followed logically. And unlike simulation theory, this isn't philosophy, it's testable physics. Juan Maldacena, 1997, Princeton theorist who proved a specific case. Take a five-dimensional universe with negative curvature called anti-de Sitter space. Everything happening in that 5D bulk can be completely described by a 4D quantum field theory on its boundary. Translation: physics in higher dimensions is mathematically equivalent to physics in lower dimensions. The 3D movie and the 2D film are the same information, just encoded differently. Maldacena's paper has over 15,000 citations. It's one of the most important results in theoretical physics in 50 years. It's not speculative, it's rigorous. It's used for actual calculations. Physicists used ADS/CFT to predict properties of quark gluon plasma. The predictions matched experiments. So the holographic principle isn't a thought experiment anymore. It's a tool, a proven and usable tool. 2 weeks before Stephen Hawking died, he submitted his final paper, co-authored with Thomas Hertog. Title: A Smooth Exit from Eternal Inflation. The argument: time itself might be a holographic projection. Our experience of time past, present, future could be emergent from timeless information encoded on a boundary. Hertog's summary: we're not really living in a universe that emerged from a Big Bang. We're living in a hologram of that universe. Hawking spent his last days arguing that our entire timeline is a shadow cast by information. Let that sit for just a moment. It sounds like our life, all of our experiences, are a 3D movie on a 2D film. And somewhere the film reel exists. The beginning, last week, yesterday, right now, and tomorrow. Tomorrow hasn't played yet, but the information exists on a reel. So here's where everything connects. In episode 1, we looked at near-death experiences. Consciousness persisting when the brain flatlines. In episode 2, remote viewing. Consciousness accessing information it shouldn't have access to. The materialist explanation that the brain generates consciousness doesn't fit the data. But if reality is information-theoretic, and consciousness is fundamental rather than emergent, then the anomalies make sense. Like Donald Hoffman, cognitive scientist at UC Irvine, his claim, space-time is an interface. Like the desktop on your computer, the icons aren't the reality. They're user-friendly representations of transistors and memory cells you don't need to understand to use the computer. Evolution optimized us for survival, not truth. Organisms that see reality as it is get outcompeted by organisms that see reality in whatever way keeps them alive long enough to reproduce. So what we call physical reality is a species-specific interface rendered for humans, by humans, or more precisely, by conscious agents interacting with a deeper substrate. Hoffman's math says conscious agents are ontological primitives, more fundamental than spacetime. Spacetime emerges from their interactions, which sounds insane until you remember quantum mechanics already told us observation affects reality. Or Bernardo Kastrup, computer scientist, philosopher, and professional antagonist. His version: reality isn't made of matter that generates consciousness. Reality is consciousness that generates the appearance of matter. The metaphor: you're a whirlpool in a stream. The whirlpool looks distinct, has a boundary, seems separate, but it's still the stream. We're dissociated alters of universal mind. If matter is a representation in consciousness rather than a generator of consciousness, then death doesn't end consciousness, it just ends the representation, which would explain near-death experiences, out-of-body perception, all of it. The problem: you can't test this. It makes no predictions materialism doesn't also make. The appeal: it solves the hard problem of consciousness by making consciousness fundamental. Sir Roger Penrose, Nobel Prize, mathematical physicist, argues consciousness requires quantum effects in brain microtubules, specifically orchestrated objective reduction, quantum superposition in the brain's protein structures collapsing in a coordinated way. 2024 update. Experiments confirmed superradiance in microtubules, quantum effects that survive longer than decoherence models predicted. Federico Faggin, inventor of the microprocessor, takes it further. Consciousness is a fundamental property of quantum information itself, not generated by complexity, present at the quantum level. Why it matters: if consciousness is quantum and quantum mechanics is non-local, consciousness doesn't need to be confined to skulls. Stephen Wolfram, mathematician, Mathematica creator, professional polymath. His framework: the Rulliad, the entangled limit of all possible computational processes. Reality isn't simulated by some external computer. Reality is computation itself. All possible rules all at once, creating the appearance of physical law through observer selection. We don't see the whole Rulliad. We see the slice of computational space that's accessible to beings structured like us. Different observers, different computational structures would carve out different slices and call them physics. It's less we're in a simulation and more we're one computational process among infinite others, all executing simultaneously, and physics is just what consistency looks like from inside, which is somehow more disturbing. Here's what matters. Simulation theory claims we're in the matrix. Some advanced civilization is running our universe on a computer. There's a programmer, an external reality, someone who could shut us off. Computational reality claims information is fundamental. The universe processes information. Physical laws are information-theoretic constraints, but there's no external computer, no programmer, no base reality above us. The holographic principle is computational reality. ADS-CFT is computational reality. Quantum mechanics is computational reality. They're all pointing to the same thing. Reality operates on information-theoretic principles, but that doesn't mean reality is simulated. Sabine Hossenfelder, German physicist, YouTube science communicator, professional skeptic. Her take on simulation theory: it's pseudoscience. Proclaiming the programmer did it doesn't explain anything, it just kicks the question up one level. Her distinction: saying the universe is computational, that information is fundamental, that physics is information processing, is scientifically defensible. Saying we're in a matrix-style simulation run by aliens, not defensible, not testable, not physics. And she's right. The holographic principle emerged from solving the black hole information paradox. It makes predictions, it gets tested. Simulation theory makes no predictions, can't be falsified, doesn't explain consciousness, quantum mechanics, or why reality has the specific laws it does. It just says, someone programmed it that way, which is theology, not physics. Simulation believers point to two things as evidence: the Mandela effect and fine-tuning. The Mandela effect: false memories shared by large groups. Berenstain Bears versus Berenstein Bears. Luke, I am your father versus the actual line, which is so very oddly, no, I am your father. Or even better, Sinbad's genie movie that never existed. Simulation interpretation, glitches, reality patches, timeline edits, actual explanation, how human memory works. We reconstruct memories every time we recall them. Confabulation is normal. Collective false memories happen because we talk to each other and reinforce errors. They also point to fine-tuning. The constants of physics, gravitational constant, cosmological constant, electron mass, are tuned to absurd precision. Change them by 1 part in 10 to the power of 120, and stars don't form. Life doesn't emerge. Simulation interpretation. The programmer set the parameters for intelligent life. Physics interpretation. The anthropic principle. We observe these constants because we couldn't exist in a universe with different constants. There might be infinite universes with different constants. We're obviously in one that allows observers. Neither of these things proves simulation, and it makes me sad to say, but both are consistent with a universe that's information theoretic and not programmed. So where does this leave us? Well, it sounds like reality appears to be computational, and that it's not speculation, but rather it's exactly what the math is telling us. The holographic principle, anti-de Sitter space, conformal field theory, correspondence, quantum mechanics. They all point toward information being more fundamental than matter or space-time. Consciousness theories like Hoffman, Kastrup, Penrose, Fagin are all converging on the same insight, but from the other direction. Consciousness might not emerge from information processing, it might be information processing. But computational doesn't mean simulated. The universe doesn't need an external real reality any more than math needs a mathematician to make 2 + 2 = 4. If reality is information, it might just be what information does when there's enough of it, structured in particular ways. And that connects to everything we've explored in this series so far. Near-death experiences? If consciousness is fundamental rather than generated by brains, then consciousness during brain death isn't impossible. It's expected. Remote viewing? If space-time is an interface rather than fundamental reality, then non-local access to information isn't paranormal. It's just accessing the substrate beneath the interface. The connection between consciousness and reality? Not mystical, structural. Which is either profoundly elegant or deeply unsettling, depending on whether you prefer your existential crises to come with equations. So maybe Elon Musk was wrong about the 1 in billions odds. Franco Vazza's math at the very least put a big damper on it. But if he is wrong, Musk was at the very least wrong in a very interesting way, because the impulse was correct. Reality does look computational, just not in the way Silicon Valley thinks. It's not that we're in someone else's simulation, it's that reality is the thing doing the simulating, and consciousness is the interface. I'm Jake Vance, and this has been a lot of theoretical nonsense. Next time, we dive deep into the theory with the most direct experimental evidence to its credit today. Sir Roger Penrose and Dr. Stuart Hameroff's OR. Thanks for watching, and thanks